All right, thank you for the introduction. My name is Visuri. I'm the first year PhD student at the University of Oulu. And with our former colleagues from Oulu who are now in Melbourne, and also Reza from Dartmouth College, I'd like to present our findings on quantifying smartwatch use. So the motivation for our work is that we want to quantify smartwatch use and investigate the differences and similarities to smartphone use. Since these smartwatches are often designed to work in tandem with the smartphone, and the relationship between these two devices is very complex. We wish to understand this connection more thoroughly. And also there's a lot of work in investigating how smartphones are used, but there's a clear need for more research on investigating how smartwatches are used, especially in the wild. Although we already got a nice presentation in this session about more qualitative approach to understanding smartwatch use. So to understand smartwatch use, we first can define sort of four main functionalities from a technical standpoint. So the first off is the timekeeping aspect. So smartwatch needs to be more like it is like a traditional wristwatch in a sense. So, and also it can display notifications and short piece of information to the user. You can interact with your smartphone applications or your smartwatch applications, which are usually such a continuing on the smartphone application with a somewhat different interface. And lastly, it can also be like a personal health monitor or a ubiquitous health monitor, for example, a step tracker or a heart rate sensor, for example. But not all of these functionalities have the same sort of a need on the user. So the previous talk, we found out that the timekeeping functionality is the most important. But then there's a bit of a controversy here because the findings we had was that the notifications functionality is actually the most important. And actually in this paper by Min et al., they found out that the novel users of smartwatches, so the new users, prefer the timekeeping aspects. But then the more experienced users who had used the devices for, say, 90 days or more actually preferred notification capabilities. So this is why these two are sort of the main functionalities, as also presented on the previous talk. And then the interactions with the applications and the health monitoring aspects are not deemed quite as important for the user. So from these, we can sort of aggregate two main functionalities for the smartwatch. So one is receiving notifications, and another is accessing the smartphone information in a more sort of covert way, without intruding, or sort of without this social, how do you say it, pressure on yourself to constantly be grabbing your smartphone. And also, both of these functionalities require a smartphone connection, so you need to be within the vicinity of your smartphone. And although there's very similar devices, the smartwatches play a very different social role than the smartphones. Right, so some related work on the smartphone use. So roughly half of the usage sessions on smartphones are very brief, so they last less than 30 seconds. And often users are likely to just flick through the applications and not spend too much time lingering on one application. And there's a term for this called micro-usage, coined by Ferreira et al. And also, when Berkel et al. Found out that roughly 1/3 of the smartphone usage sessions are actually users continuing on something that they had previously been working on, instead of starting new goals. And lastly, users receive a lot of notifications on their smartphones, so more than 6 notifications daily, and most of these come from communication applications. And then some findings from smartwatch use, in addition to the previous results by Min et al., is also a lot of the smartwatch use is actually driven by these short glances to the device. So over 2/3 of the usage sessions are these very brief sessions. So in order to find out how these smartphone usage characteristics translate to smartwatches, we want to investigate if and how these trends translate, and especially in terms of notifications and the associated usage sessions. And then what are the key differences between these two devices? So in order to do this, we collected a data set over the first half of 2016 from 377 users so all of these users are Android smartphones, so no Apple Watches or devices like Pebble or Fitbit. Most of the users contributed data for 30 or less days, roughly 1/5 for up to 3 months. And then we also had 18 users who contributed data for more than 90 days. And in all, we had 3 million notifications arriving and 800,000 screen events. And the notification always come with associated timestamp of arrival, and then also the application that sent the notification. And the screen events are simply screen turning on or off, and these indicate usage sessions. So when the device is on, we assume that the user is using the device. And then in order to categorize the different notifications and usage sessions, first of all, we start off with the notification outcomes. So here on the figure, we can see that the red dot indicates an arriving notification. The black dot and the line is a time threshold. And then the colored block is a usage session. So on the left side, we recognize a notification that was promptly observed, a term we use on our paper, meaning that there was a following usage session to the notification within this 60-second time window. And then on the right side, we can see that this notification was not sort of promptly observed. And that threshold of 6 seconds is based on this large-scale assessment on mobile notifications by Zhanna. And then similarly, we can also identify different session types, so whether the sessions are initiated by the user or by an arriving notification. And we can call those sort of proactive and reactive sessions, respectively. And we have the same color codes, but here we're just sort of going back in time from the beginning of the user session to see whether there was an actual notification arriving before the session or not. And then we can sort of categorize session types and notification outcomes based on these. And here you have a summary of how many of the sessions are each type and how many notifications are observed. And then we also recognize that roughly 1/5 of the usage sessions actually lasted for exactly 5 seconds. And we figure out that this is probably like an automatic time threshold for the smartwatch screen to turn off if there's no interaction with the device. So then we can realize that we can categorize these events as sort of peaks to the watch. So sessions where the user has no interaction at all with the device. So he's only consuming information that's coming to him. And then we categorize each session based on this, its length to these peak sessions or interaction sessions. And then moving on to the results, so how our smartwatch actually used. So in terms of usage sessions, we can notice that the number of usage sessions varies during different hours of the day. So the majority are afternoon and sort of early evening. Interaction types also vary during different hours, so these peak and interaction sessions. And the peak sessions are more frequent during after work hours, so after 4 p.m. roughly. Of course, depending on your work schedule. And also the notification in the use also varies during different hours. So the notification in the use is more prevalent during work hours, so from 8 a.m. to 5 p.m. And we can sort of see a correlation with the second and third point here, that likely when people are working and have less time at their disposal, they're more likely to just react to incoming cues. And then after work hours, people with more time at their disposal, they're more likely to use the smartwatch on their own volition. And then looking at the session duration, so how people use their smartwatch according to the session type. So again, this peak or interaction session type, notification is used as well. So we can recognize that notification use usually lasts longer, so roughly 11 seconds opposed to roughly 8 seconds for the user-initiated use. So this of course indicates that when there's an incoming notification, you are likely to either consume the information or do something. For example, since the smartwatch screen is really small, so it might be hard to read a large or a very long lengthy text message. You might have to browse through the message and thus interact with the device for a short period there. And also the user-initiated use very frequently lasts exactly or less than 5 seconds, indicating that many of these user-initiated sessions are actually cases where the user is simply glancing for the time of the day, or it's glancing for new incoming messages, even if there's no cue or any type of other vibration that indicates that there was something new. And lastly, the session duration is significantly shorter than the smartphone sessions. So roughly 10 seconds on average for this smartwatch. But then, for example, in this paper by SIGCHI et al., they recognize that usual smartphone mean duration over the day is something in lines roughly 4 minutes and slightly above this. So in order to investigate this difference more thoroughly, we aggregated some data from 4 previously released papers on smartphone data, and we had 445 users who had contributed data in these data sets. And then we aggregate this data into daily statistic of use, so the number of daily usage sessions and then the mean duration of the daily usage sessions. And here we can clearly see, so for the back row, you can see properly, the left or the y-axis indicates the number of sessions, and the x-axis is just the mean duration of the session. And then the red dots indicate smartphone sessions, and the blue dots smartwatch sessions. So you can clearly see that there's a drastic difference in how frequently and for how long people interact or use their device in terms of these usage sessions. So then to understand sort of what are the possible elements that contribute to these differences. So again, as it became evident in the previous talk, there are limited input capabilities on the smartwatch. So people are less likely to engage into too long interactions with the smartwatch. And also, this makes these devices, the smartwatches, more suitable for consuming content rather than trying to generate new content or respond to messages, for example. Another element is the device placement. The typical placement is on the wrist, so this allows for quick interaction. And this also explains the high number of daily sessions, so it's really easy to access the information on the smartwatch. And lastly, since the smartwatch is also used as a timekeeping device, this also is likely adding to the number of these short interactions. Next, some statistics from the notifications. So roughly 10% of all notifications result in these interaction sessions, so in sessions where the users interact with the device. And this contains both the observed notifications and the ones that the user interacts with more than 1 minute after the arrival of notification, so it can be even like up to 30 minutes. For notification initiated use, this interaction session length is significantly higher than overall. And the mean delay for arriving notifications for the user to see the arriving notifications is roughly 23 seconds. And then, interestingly, there's a higher portion of peak sessions in when the user has a session that's notification initiated compared to the overall. So, meaning that when the user sees a notification, he's less likely to interact with the smartwatch than when she's actively using the device. And also these peak and interaction sessions frequencies are significantly different for the different notification sources. So in this case, we aggregate the Google Play Store categories for different applications into these generic categories. And then here on the plot, you can see that the lighter color indicates an interaction session frequency, and dark color the peak session interaction frequency. The peak session frequency. And here you can see some very clear differences. For example, for communication apps and internet social apps, people are more likely to interact with the smartwatch. And then for maps and travel applications and media applications, they are more likely just due to short peak sessions. And the selected use is based on the source of the notification. And it's very similar to what's observed on the smartphones as well. And these results also match the survey results in previous works on smartwatches. Then, to summarize these notifications characteristics, there are some benefits of smartwatch use, although, as claimed in the previous talk, some of these benefits can be sort of a two-edged sword at the same time. So both the ease of access contributes to both. So the smartwatch is a good tool for communication and social interaction applications, and also can be a good tool for navigation, since you don't have to can be even less dangerous to drive a car and check your navigation instructions from your smartwatch, for example. And then some findings and takeaway points. So first of all, users frequently use their devices for short periods of time. The smartwatch uses the same functionalities for receiving information than smartphone, but in a more quick and convenient way. And thirdly, the standalone smartwatches could build on these aspects these unique aspects of smartwatches that have not been observed on the smartphone previously. And then to conclude, we have identified that smartwatches have very unique usage characteristics. Users prefer similar content on both devices, so meaning that the content and applications that users want to access are similar on these both devices. And lastly, there's also room for more smartwatches to be extended, either by creating like novel interaction methods, or just leveraging simpler interaction methods, because we can see that the smartwatch interface and the screen are not very suitable for very complex interactions. So applications should sort of leverage these very simple interactions which users can easily basically use. And our findings should be taken into consideration when designing these new devices and smartwatch applications. All right, thank you for attention. I want to also say that the data collection in our work is continuous, and we are all open to collaboration. So if anyone are interested in collaborating with our data sets, please shoot me an email. All right, thank you.
So this is great. Do you guys have some questions? I'll pick it up.
All right.
Okay. I would like to. So you said you are willing to share the data set or work together with people that are interested in the data set. And you also said you focused on Android smartwatches. So my question is like, I mean, if I look at this work in terms of a method and techniques, is there something that you could share with other people so that they could perform similar studies? Did you develop some tools for it that you would be willing to share, or is there a framework behind it? You didn't talk about the instrumentation of the devices so much. So that's my question.
Yes, so our analysis was done sort of on our PCs, basically. There was no sort of framework behind the analysis. But I'll be more than happy to share the code and share the methods we used. And also, many of our methods are very in a way, simplistic, and they are also described on the paper in detail.
But I was also thinking in terms of data collection tools and things like that. Yes,
so the data collection tool we used was this application called Insight for Where. I think
Aware from Denzil, okay.
So, no, it's also from College, from Reza. So it's Insight for Where. And this is an application actually available on the Play Store for anyone to download. So this is how we collected the data. So, and we have access to it, and we are, like I said, more than willing to share this data set if anyone wants to get access to it.
Okay, that's great.
I'll ask a question.
All right.
Daniel Verhali from FXPL. Thank you for the talk. I wanted to hear your thoughts on maybe.
I think it's recorded, so
It gives you a lot of prep time for what's coming, right?